So again, we'll look at the distribution of arrival times for fire trucks arriving on a scene. It is uniform with a minimum arrival time of 2 minutes and a maximum arrival time of 15 minutes. We can calculate conditional probabilities using the uniform distribution. We could ask the question, what is the probability that a fire truck will arrive after 9 minutes, given that 5 minutes has already passed? So we could write the probability as such. It's the probability that x is greater than 9, given that 5 minutes has already passed, so x is greater than 5. And there's one way to do this. Well, there's two ways to do this. The first is that we can look at the revised sample space. So the entire sample space is the entire rectangle. It goes between 2 and 15. This is the original. But now remember that 5 minutes has already passed. So, excuse me, what we could do is just look at that portion of the rectangle that starts at 5 minutes and comes up to 15. And then we could ask, what's the probability that the fire truck is going to take longer than 9 minutes? If we do it this way, this is the revised sample space. This is our new sample space. And we still do the same thing. We're going to calculate the area of that rectangle. The area of the rectangle is base times height. So the base, given here, goes in between 15 and 9. So 15 minus 9. But now we have something different, right? Because it's the new sample space, the entire rectangle must be equal to 100. So we have to figure out, what is this new PDF here? Well, we'll do it the same way. This occurs, what's this? This value of y here is 1 over b minus a. So in our case, 1 over b is still 15, but a, instead of starting at 2 now, is starting at 5. So when we do this, 15 minus 9 is 6, and 1 over 15 minus 5 is 1/10. So that's 6/10, or 0.6, or a 60% chance. Okay, so this is the new probability. And that's how you do it using the revised sample space. Now, we can also use our definition of conditional probability. Remember, the conditional probability says the probability of A given B will be equal to, the numerator is the probability of A and B, and we divide that by the probability of just B. So let's write that for us. The probability that x is greater than 9, given that x is already, 5 minutes has already passed, so x is greater than 5. The first event is the probability that x is greater than 9. So that's the probability of A, let's see, and, I'm sorry, let me erase this. So A is x is greater than 9, and we have to determine the second event, which is x being greater than or equal to 5, and then we will divide that by the probability that x is greater than or equal to 5. So you might think to yourself, well, what is this? Where is x both greater than 5 and x greater than 9? Well, here's 5 and here's 9, right? So x being greater than 5 is this set of numbers. X being greater, I'm sorry, that should be an open circle. And then x being greater than 9 happens here. And so the overlap is the and statement. It's the intersection of both of those, and that is just where x is greater than 9. So we can simplify this entire statement and say the probability of x greater than 9 and x greater than 5, that's really the same thing as the probability of x being greater than 9. And we divide that by the probability that x is greater than 5. Okay, so let's just draw these out then. The probability that x is greater than 9. Again, here you keep the original sample space. So we are looking for this portion here. So the probability that x is greater than 9, that has the base. So the base goes in between 15 and 9, and the height. Now the height stays the same because we're using the original sample space. So 1 over b minus a, which is 1 over 13. And when we're done calculating this, we get 6 over 13. So that is the probability that x is greater than 9. Then we can look at the probability that x is greater than 5. So inside of here is 5, and we're looking for this probability. So the base goes in between 5 and 15, so 15 minus 5. The height, we're using the original sample space, which is 1 over 13. So when we're done, this becomes 10 over 13. Okay, so now we just have to plug this into the formula. So the probability that x is greater than 9 is 6 over 13. We divide that by the probability that x is greater than 5, which we found here, and that is 10 over 13. And when you're done, what we'll get is 6 over 10, which is the same. There is a 60% chance of this